Okay, today we'll talk more about characteristics of polynomials, and we're going to look at ways of factoring when we can't use any of the other methods of factoring. We just have to do synthetic division. If we know that it's a factor of the polynomial, then we could do synthetic division to find the other factors. If we don't know a factor, then we have to guess and check by doing synthetic division. There are a lot of, we don't know where to start, we don't know what number to guess, so we want to look for ways to narrow down our choices so that we don't have to try too many guesses. And that's what these are looking at. They are methods to narrow down the guesses that we have to make. If we want to factor this and we're trying to do synthetic division, we don't know this, and we just have to guess and try whatever number we think of. We want to narrow down our choices. So here's one way to do that. So what should we guess to use in synthetic division? We take the factors of the leading coefficient, and that's usually represented with a Q. And we take the factors of the constant term, and that's a P. So here we'll have 1, 2, 3, and 6. And we have positives or negatives. And then we just write P over Q. And so we put all of the P's over all of the Q's. So we have 8 choices that might work. At least we're not going to try 4. And all the fractions, we want to try these integers. These are called the possible rational zeros. Maybe none of them work. It's possible that none of them work, so it's still not the best choice, but it's what we have to deal with. All right. Find the possible rational zeros. So we get Q is going to be all the factors of 2. 1 and 2, positive and negative. And then we'll get P is all the factors of 36. 1, 2, 3, 4, we get a lot of them. 9, 12, 18. And then we have to put P over Q. So let's take all these numbers and put it over 1, and then all of these numbers over 2. So all the P's go over 1, and then all the P's go over 2. And we get some repetition here. This is 18, and we already have 18. This is 9, and we already have 9. This is 6, we already have 6. We'll keep that. That's 3, we already have 3, 2, 1.5, 1. And then it's going to be positive or negative for all of these. All right. Then we have to guess one of these numbers to use with synthetic division. Find the possible rational zeros, then find the zeros. Forgot to write that. So if it just said find the possible rational zeros, then we're done. If it says now find the actual zeros, now we have to do synthetic division. All right, so those are the coefficients: 2, -4, 18, -36, 2, -4, 18, -36. And I already know which one works, but when you do a problem out of the book, you won't know which one works, and so you might have to try this a few times. If that's not a 0, then that's not a 0, and you're going to try again. So I tried 2, and you would just keep trying keep trying numbers until they work. Once you get down to 3 numbers here, don't do synthetic division, because now we're down to a quadratic. And we could say that's 0x plus 18, or 2x squared plus 18, and that equals 0. So we have these are zeros, and then we have x equals 2 from up here. That's the other 0, and we have 3 zeros. Okay, you pause it and try this one. And we don't get any repeats here, so now we have 8 times 2, because it's positive and negative. We have 16 possibilities to try. And let's try -2. we can factor like this, and we'll get a 12 and a 1. 12 times 1 is 12, make them negative, and we'll add to get that. And it all multiplies out correctly, so we have 3x minus 1, x minus 4, and that equals 0. One third, and then we also have so we get 3 zeros. All right, let's talk about upper and lower bounds. All right, so when we do synthetic division, if you divide by a negative number and the answer is alternating positive and negative, then you don't check any numbers below C. If C is positive, and the answers to synthetic division are all positive or 0, then don't check a number that's greater than that. So here's how it looks. So we're dividing this, we're going to check 1. We want to know, is it an upper or lower bound? So and 1 is a 0, so 1 is something we want to keep. But now if we have to check more numbers, we look at this and see that they're all positive. So we say that 1 is an upper bound, meaning don't try 2, 3, or 4, 2, 3, 4, 5, any of those bigger than 1. Let's look at this. So negative 2 is a 0 because we get that no remainder, but we have alternating positive, negative, positive. That counts as a 0 counts as either one. So we know if we were going to check again, we wouldn't check a number lower than negative 2. Let's try this one. So 1 is not a 0, but we don't have all positive and we don't have alternating. So that means we could check higher than this or lower than this. It's not an upper bound and it's not a lower bound. Here's another way to limit our choices in guessing. We look at the sign changes in the polynomial. We can look for the possible positive zeros, and we do that with sign changes in the polynomial. We can look for possible negative zeros, and we do that by looking at sign changes in f of negative x. So here's how it works. If we have g of x and we look for the number of sign changes, negative to positive, that's a sign change, and positive to negative, there's another sign change, negative to negative, no sign change. So we have two sign changes, and that's going to mean we can have 2 or 0 positive zeros. And whatever number we get, we just go down by, we have to go down by 2. So we wouldn't say we have 2 or 1 or 0. It's 2 and we skip 1 and we go to 0. If we had a 3, we'd go 3 or 1. Sign changes in f of negative x. Now we go g of negative x and we plug in we put in a negative x and apply the exponents. So that's going to be a negative, negative, positive, negative, negative. And we look for the sign changes. We only have one sign change. So that means there's one sign change. So that means we have 1, negative, 0. And that's helpful because once we find one negative 0, we don't look for more. And I'd say that's more helpful than this because here we could have, well, I guess they're about equal. Okay, so for this one, let's look for the positive zeros, and we will do Look for the sign changes in that. So we go positive, positive to negative, negative. So that means we have 1, positive, 0. And let's look for the negative zeros, and we'll put a negative x in there. Okay, negative 1 to the 5th is negative. Negative 1 squared, positive. Negative times negative. And we look for 1, 2. Negative to positive, positive to positive, no sign change. We have a sign change there. So we have 2 or 0, negative zeros. All right, pause, try that one. And we're looking at positive zeros. We'll have and we're going to go 1, 2, 3. So we have 3, 4, 1, positive 0. Let's look at the negatives. I'm putting negative x. All right, even power, and we're going to get a positive. That'll be a positive, so we'll keep the negative there. Negative, negative 1 to the third is a negative. Square it, we get a positive. Negative times negative is positive. So here we have negative to negative, negative to positive, positive to positive to positive. So we're going to have one sign change, and that means we have 1, negative, 0. Alright, so let's put all these to work. We want to look at the possible rational zeros. We'll look at Descartes, and we'll also look for a bound. So possible, or go ahead and pause it. You try all the strategies. We're going to look for possible rational zeros by using P and Q. Look for Descartes' rule of signs, or use the rule of signs to check for how many positives and negatives. And then as you're doing the synthetic division, look for the pattern in the answer to see if you should check a higher number or not. Okay, so Q comes from the 1, P comes from the 12, and we're going to get 1, 2, 3, 4, 6, and 12. And then we have to do P over Q. Put it over Q, and we have all of these possibilities. Let's look at Descartes. Sign changes in the original. Positive zeros, we'll look for x to the fourth positive to positive to negative to negative to negative. So we will look for 1, positive, 0. And let's look at the negative, possible negative zeros. We need to look at what happens when we put a negative. Positive, that'll be a negative. Positive, but that'll stay negative. Negative, negative is positive. And we have positive to negative, to negative, to positive, to negative. So we have 3 or 1 negative zeros. And now we can guess. And we're taking the coefficients, 1, 2, negative 7, negative 20, negative 12. All right, let's guess 1. So we know 1 is not a 0 because that's not 0. And we look for a pattern here. They're not all positive, so that means we could check a higher number. This is not an upper bound. So let's try 2. Okay, 2 is not a 0, and we don't see all positives here, so that means we could check a higher number. Alright, 3 is a 0, and we see all positives are zeros, so that means 3 is an upper bound. We wouldn't check anything higher than 3, but also we know there's only one positive 0 anyway, so we wouldn't check beyond that. 3 is one of the zeros. And now let's look for some negative zeros. Make sure we use the 1, 5, 8, 4. And let's try negative 1. Alright, we don't want to keep using the full polynomial over and over, because once we get down to 4 terms, then we're going to get down to 3 terms, and now it is a quadratic. We can factor. So we see that x equals negative 2, and for the solution, we have x equals negative 2, x equals 3, x equals negative 1, and those are the solutions. And this 0 has multiplicity 2, so we went over multiplicity previously. All right, that's it.